Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 24. So the question is, a positively charged particle is placed at the origin with zero initial velocity in the presence of a constant electric and a constant magnetic field along the positive z and x directions respectively. At large times, we need to find out what will be the overall motion of the particle adrift along the possible direction we need to find out. So 4 options are given and we need to choose the correct option. So let's get started. Now this question comes from the section Electromagnetic Theory and the concept involved here is the Lorenz Force. So what is the Lorenz Force? Now if a charged particle is placed in presence of an electric and the magnetic field, then Lorenz force is the force on the charged particle due to the electric and the magnetic field. It is expressed as F is equal to QE plus V cross B. Here F, E, V and B are vectors. So here Q is the charge on the particle, QE is the force on the charged particle due to electric field, and Q into V cross B is the force on the charged particle due to the magnetic field. Now the difference between the force due to electric field and the magnetic field is that in presence of electric field, the charged particle will always feel the force. But in case of a magnetic field, the charged particle will feel the force only when it is moving. Now in the given case, we have a positively charged particle placed at the origin with electric field along z direction and magnetic field along x direction, that is positive z direction and the positive x direction. Now it is given that the initial velocity of the particle is 0. So what will happen when the initial velocity of the particle is 0? That means there will be no magnetic force on the particle due to the magnetic field. However, there is an electric field force due to electric field. Now we know that the electric field is along the positive z direction. So therefore that force due to the electric field will also act along the z direction. That means the particle will also start to move along the positive z direction, or we can say the velocity of the particle is along the positive z direction. Now once the particle gains the velocity, what will happen? So here the force due to the magnetic field comes into picture. Now this magnetic force will act along positive y direction initially. Why initially I am saying, I'll explain it. But initially the magnetic force will act along positive y direction. So here now positive y direction because the magnetic field is along x direction. The velocity of the particle is along positive z direction. So magnetic force is as you can see the expression, it is V cross B. Therefore the force direction will be perpendicular to both the direction of the magnetic field as well as the velocity of the particle. So it will be along the positive y direction. So now this why this magnetic force will come into picture now, because till the time the particle does not have any velocity, because of the expression V cross B, the magnetic force will be 0 when the particle is at rest. Once it gains the velocity due to the electric field, then the magnetic force will comes into picture. So the particle which just started to move in the upward direction of, that is along the electric field direction, now because of this magnetic force along y direction will now gets deflected. So now this deflection, because of this deflection, see here you need to understand this thoroughly. First of all, now the direction, we know the direction of the magnetic force is perpendicular to both V and B, and because of this it will be initially along the Y direction. Now the reason I am saying initially, because once this force changes the direction of the particle, that is, it starts to deflect, so the velocity direction is changing. Now we know that this magnetic force expression contains the term V cross B. So therefore, since the direction of velocity is changing, therefore the direction of force will also change. When the velocity direction is along this direction, force is along this direction. Once it starts to deflect along this direction, the force direction will change. It will be towards this way. So what will happen if the direction of force will change? It will further deflect the particle towards away from this electric force or the electric field direction. So instead of this, it will deflect along this direction as it further moves. Okay. So once again the direction of the particle is changing, means again the force direction will further change. So again it will take further away the particle. Okay. So gradually as the particle moves, so what will happen is, therefore here the direction of the particle will also change. The velocity of the particle change, that means the direction will also change. So what will happen is, eventually the particle, because of this change in the direction of the magnetic force and the velocity, the particle will form a curved path, and eventually the velocity will reduce to 0. Because at certain point of time, the magnetic force and the electric force completely counterbalance each other. So at that point, the velocity will be 0. So again, the cycle repeats. So this eventually form a motion called cycloid motion. So such kind of motion is called cycloid motion. Now our question is, here, the question is here, at large times the overall motion of the particle is adrift along which direction? That means overall motion. As you can see, this motion is taking place in YZ plane. But the overall cycloid motion is progressing along the positive Y direction. So we can say that the motion of the overall motion of the particle, we can say it is along the positive Y direction. So the answer for this question is positive Y direction. Now let's check the option. Now if you look at the option, you can see that option A is matching with our result. So correct answer for this question is option A.